Okay, so again, good morning everybody and welcome back to the Attack and Research track on the second Troopers Day. Today in the morning we will start with Atilla Marosi. He's a security threat researcher from Sophos and he did a kind of interesting analysis and case study about FinSpy. FinSpy is, at least in Germany, very well known as spying software. So I think it will be kind of exciting what he found out. So Atilla, your time on the stage.
Thank you. Good morning for everybody. Thank you to having me. This is my second Troopers. The first, when I get some information, I thought that it would be a nice conference, but now I know that is one of the best, and that was the reason I must be here. So the presentation is Hacking FinSpy, and my name is Atilla Marosi. Okay, so about the topic, FinSpy, FinFisher, Gamma Group, so the phenomenon. There was I think everybody heard about it because it was very active in this community, they speak about it. So there was a big data leak. The middle of the last year, there was 40 gigabytes data was stolen, roughly everything, application, brochures, release notes, full support databases. Every interesting stuff is on the WikiLeaks, summarized and detailed. Brochures are there, so if you are interested, you can check it. So after that, we know that what is the ability of the application, but I would like to know how it made technically. So how they solve the encryption part, how they solve the communication, the configuration, so the technical part of it. And this is a very special malware because this malware was created by the good guy for or against the bad guys. So I think it's quite unique. And which is very interesting, I think the question is there any weaknesses which could be used to exploit this stuff? And what is the quality of an application like this? Because it could be used legally against good or bad people. So it has to be a very good quality, I think. So what was in the leak? I was focused only just the AP key stuff because there wasn't any interesting or detailed analysis that time in the AP key version of the FinSpy. So that was my target. In the leak, the first version which was leaked was the 4.21 and the latest was the 4.51. So these are the version we have. The first wasn't obfuscated, which was very good for us. Makes the analysis much easier. And the latest version was is much powerful. It has root stuff and it's are able to make screenshots. It's obfuscated, but the basic stuff is the same. So if you know the original or older version, it's much easier to analyze the newer version because you just find the new stuff and the basic concept is you already have. So how to analyze, how to have a quick look about an application. I use these tools roughly to get inside information. The first, I think, is AP key, which are used for extract data from AP keys. Dex2jar, GD, JAD, these are very common. And which is not so popular, but I think it's very good application, is EG Logger and apksmash. This combination is very powerful. I will describe it. So the permission which is needed for the application is quite big range you need it. That's cover the main functionality of the phone, so you will be able to monitoring all the stuff which is going with the phone. So actions which are interested by the application is also incoming calls, receiving SMS. They are monitoring the health of the device, so battery state and device state, not to be too aggressive or something. So if you burn so much energy or using so much storage on the device, they are able to recognize it and turn the speed down, not to be so annoying. So these are the interesting actions which could be noticed. The services and the receivers in a unobfuscated version, the names are very good. That the service is like a WhatsApp service, which is I think it's easy to figure out. The tracking service as well. So in Android, services the things which continuously running in the background. So if you put the application in background, it's still running. So these are the core function of the application. There is a remove at service which is unique, I think in malware area. I will describe, and which is very interesting. The SMS receive, if this action has occurred, that the phone is receiving an SMS. This class will be notified about the event and the content of the event. So the data of the SMS will be pushed to the class. So apksmash, as I mentioned, it's a very good application. It has two features, or you can use it only one or both of. The first is just seeking over the small code for interesting stuff, strings, expressions, and it will be summarized in a report that which part could be interesting for you, where is an encryption, where is a database stuff, or device checking. So if you would like to quickly analyze an APK, just execute it and you will get a detailed report which class could be interesting for you. And if you use it with EG logger, it could patch the original Smallify with EG logger in an interesting part of it. And when you upload the application, the modified application, to the device and running and poke it in different way, it will be trace out and log out all the activities. So you will get a trace log how the application works and what happened if you send a message or something. So in this situation, when the application started, these methods are called. So on create, okay, it's normal. Make configuration file, it's interesting. Get configuration extract, PKey signature, and finally there is a base64 decode. So just read over and you will be you get an idea that how this works. And for example, if you send an SMS message to the device, it gives the activity and the data, and the base64 decode also code. So maybe it would like to do something with the SMS in a base64 way. So maybe that will be the good way to communicate the application. So it's a very fast way to get a view about the ability, the function, and the behavior of the application. So if we have to deal with malwares, I think the first thing you have to figure out how it's configured, how it's controlled, but to be controlled, you have to configure it. So the configuration is always a very, very interesting and focused point. In this, FinSpy and Gamma Group has a very good way. I think it's a very good way to deliver configuration. They use empty byte files to create a very detailed zip file, and they just use the records in the zip file to deliver information, because in the zip file there is a table of contents, and in this table of contents you have 2 and 4 bytes for attribute, internal attribute and external attribute. And if it's not used, you have 6 bytes each file. You can put something there. So they use these 6 bytes to put a piece of the base 64 to the zip file. So that was the way how they split the original B64 string and split it to pieces and put to these 6 bytes pieces. I didn't write a script to extract or analyze the thing. I just copying the original source from the malware. I created a new Java project, put the original source code of the malware, that part of which belongs to the extraction, and I use it to extract the configuration. I think it's a refactoring or something, so you don't have to write cool stuff. You can use the stuff of the malware as well. So if we analyze the configuration, there are very interesting properties and things we found. So the first is there is a heartbeat interval, and in FinSpy everything is based on heartbeat. So heartbeat could be triggered by time, that's rare, and it could be triggered by event. So they do not make communication just because, they always have a purpose. So you have a new message, okay, it's interesting stuff, I will send this information to the master, or you change the SIM card or something, so that would be the trigger of the communication. There are 2 non-traditional property, remove a day. So with configuration, they can declare a day which end of the infection. So if the phone reaches that day, it just disinfect the phone. It comes from, I think, the law. Most of the country has a strict law how you would be monitorized, and they always have a time frame for it. So there is no chance to infect the phone and just let it infected, and because maybe there will be something interesting. So there you have to declare a phone. Because it's a test data, that's the reason it's 0, but it could be a time. So the other interesting, what if there is no connection with the proxy? So they get, so lose the control. You have to declare a time frame when it has to be disinfected, because you lose the control, so you don't know the phone is used by your targeted person, or maybe just sell it, or it's for. So you have to be sure about not to monitorize or do malicious stuff with innocent people. So proxies, proxy ports, traditional, it's not interesting. This value is the worst, I think. This is the TGUID. That's the AS key. That's the only part of the AS key which could be configured by the customers, a user, the intelligence agency, the police agency. So that's the only ability they have that's their own encryption key. So that's 4 bytes. It's a 4-byte value. And there is two numbers. One is a master phone number, which could be used if you do not have a good network connection or you use this way for communication. The phone can control and give data by SMSs, so it could be a valid data channel. And voice phone is a special phone number which turns the device into spy mode. So if there is an incoming call from that number, the phone turns to in spy mode. So these are the heartbeat events. So what kind of events you are interested in? So you can configure the device as you would like to. And this is the interesting part, I think, the restriction. So you can configure which way could be used for communication. So maybe you turn off all the ways and you just use, for example, the 3G, which is quite tricky to monitorize. So if someone someone would like to monitoring the network, 3G network communication, you have to use something else or VPNs or something, because in Wi-Fi it's very easy to monitoring network connections and data, but in 3G is difficult. Or if they want it to be silent, just turn all options off and the application will do nothing. You can also configure which modules you would like to use during the monitoring session, which also means that the application always carrying all the functionalities, all the modules, which not a good idea, I think, because if you lost the application, you lost all your modules. So after a quick analysis, I found a way how to detect the FinSpy. If a device is infected with this application, with this way you can detect the exist of the application. So the receive part, the SMS receive part, that's the code part of it. So the data of the SMS just decoded as a base 64, so it has to be a base 64 string. It turns to byte array. The first 4 bytes, it's not interesting, it just skipped. The second 4 bytes is an integer, and it could be 2 integer. And in this situation, you enter this part of the code, and finally, it's abort the broadcast. So that means if you put one of these numbers in the right position, decoding it base 64 and send it to the phone which is infected, that will abort the broadcasting, so you won't get the message. So it won't be notified about a message has received. So that's the byte part of it. In FinSpy, everything is type length value, length type value. So that's the data structure. So the always 4 bytes for length, 4 bytes for type. It's 4 byte length, type, and data. And the data could be another packet. It's a very easy and old technique in network protocols. The type length value as a data structure. So let's infect this device. So I have a FinSpy here, and I just install it. And that way could be most of the times the real way, because spying agencies, police agencies, most of the time they have the ability to get the phone in some circumstances and then get infected. So it's not over the world, because most of the time they are just locally focused. So most of the criminals are there on the country, in different parts. So there is no need to infect someone other part of the world because it's not your target person. Your criminal is locally, and maybe you can deal with the infection. So now the FinSpy is installed, but it's not finished. Yeah, and so there is no file in a folder, but now I send a message to this device, an SMS message. There are plenty of activities which can trigger to start the FinSpy. So here is the device, and if everything works properly, I will receive a message there. Yeah. So it works. And yeah. So there is a new file. So the application just started, and it's extract the configuration data from the AP key, and it's saved in a private folder as a 84C dot, and that's the file. This version, it's an old one, so the configuration file is not encrypted. So as you can see, it's comma, quality of service device, departure, and there are some phone numbers. So that's the configuration of the phone now. Okay, so we have a device and install it FinSpy on them. So how to debug? That was very easy because just read over the code, figure out what should be good, and we could do this. But if you would like to reverse engineering full protocol services and stuff, you have to debug the application because it's difficult to make it in paper or in mind because it's difficult. So repapking could be the easiest way to solve this problem. Just extract the AP key file with AP key 2 minus D, which means it will be a fake Java file, and it could be opened with Eclipse, and it could be used to debug the application. So, and then you have to spend so much hour in a debugger to trace and step over and figure out how it works. If you don't want to touch the application, it's a difficult part. You have to use other way. For example, use the Zigota to waiting for new application, and if there is a new process, just hooking into the process, which means you don't have to change the AP key, which means you change the signatures or something. So that's a better way to monitorize, and this way you can change the application as well. So if there is a annoying functionality or something, you just ignore it or turn it off. So the next step, the network communication, which should be checked. It's always interesting what the network protocol, how the application, how the malware would like to communicate with the server, which is in a configuration. So I just create a fake server. It was very difficult, and use IPT IP tables hijack command to catch the communication and to emulate a fake one. So what was the packet I received? Now we know that first 4 byte is the packet size, the type of the packet, and the data. Okay, and what is this data? This data is just the email number of the phone. The phone which just infected. So that means the first packet contains the email number of this phone, and you will see why it's very, very creepy. And then here is the encrypted part of the data. So if we get it, we have to focus on the encryption part. So that's the Python implementation of the encryption part of the application. They use 2 embedded key. These keys are continuously used, and that's the only key what is used. So that and this. And the only possibility to change is just the 4 byte which comes from the configuration file. And this is 4 byte. They turn it into string, so it will be 8 byte, but we know that the source was 4, so it's 4. And that's the way: push the original key, push the sub key, get a digest, that will be the key, and second, that will be an initialize key, and that's the encryption. All the FinSpy has this solution. And in my droplet in DigitalOcean, I just start my script. It's a very dummy script, which can seek over with the pcap file, seeking for 2 4 bytes, which could be good to pick up the right packet. And then here is the encrypted part, and just brute force it, because the biggest part of the AS key you already know it, so just 4 bytes you have to brute force. And in this situation with this value, it takes only 4 minutes for a $5 cloud server. If you are not so lucky, so means the end of the space, it maybe takes 30 hours in a Python code. So it's not a real and not a good way to encrypt something. In a normal device, in a normal way, you can defeat this encryption in minutes. So, master command. If you remember, there are 2 numbers which could be good and ignored by the application. So it's just stop the broadcasting. So these 2 types of message is interesting and used. The first is the master command. Master command has 2 purposes. First is acknowledgement the previous and send some new. And these commands could be uninstall the application immediately, because there is some trouble. You can force the SMS way with this command, or you can force the network connection, testing purpose, or you have new configuration or something, just send a message to the phone, come to home, and I have to tell something to you, or something. And you can start the tracking service and stop it. So if you would like to track someone, just send a message, tracking is started, collect the data, and when you would like to finish it, just send a different type, and it will be finished. I think the SMS is a very good way, because most of the part and word GSM service are available, so you won't lose the control over the device, because it's much stable than the network connection. So receiving SMSs is very, very, very common, I think. So how a command could look? So that's the command, and here is the most interesting thing. You can control any device if you know the email number of it. So that's the only filter. So, and as you remember, it was just sent it over the network clearly at the first packet. And if you turn the phone, most of the phone has this number in the backside. So it's not a very good validation stuff. And it doesn't matter who sent the messages. The only filter is this message is for me or not. So it's again an interesting thing that why. So if you know the email number, you can control the device. So just test it. That's our device. So I send the message. Yeah, it's sent. And if everything's perfect, I won't get anything. So the only message I have is this, and there is no other messages because the application just decode the base 64, get a proper number of it, and okay, it's this message. There is no business with this, and just ignore to broadcast the messages. So and if we check the file, as you can see, there are plenty of new files because to be properly installed, FinSpy required one good master command. So if you install it, it won't work. You have to send the proper message from the master, and that will trigger and finish the installation. So now the application just seek it over the phone, collecting the stuff which was configured to be collected, and now it's properly working. So the second number is the master configuration. So you not just control, you reconfigured by SMSs the phone, which could be very helpful if you lost the control, because if you know the number and you know the email number of the phone, you can reconfigure the whole device. So it could be very useful, but as well very dangerous. So what property could be configured? Host, port, phone, which is the master phone number, which is the emergency phone number. So you can configure your phone to be an emergency phone and listening the things which goes around the phone. The save mode means that you would like to add something to the configuration, or you would like to override the whole stuff. And the heartbeat events and the restrictions, as I already described, and which is interesting, the counter, you have to send a message which has a bigger number than the last valid number, last valid SMS has. So if you would like to hijack the phone, you just send the message and send the biggest integer you have, in representing 4 bytes, and that means that was the last message what is accepted by the phone. So you can lock out everyone else with this message. So how it looks like. So the email number, what is the server you would like to use, the port, the phone numbers, what kind of configuration you would like to use, so you can set everything, and that's the number of the message. So test it. So now, if you remember, it was originally yeah, so gamma internal and phone numbers. So that's the configuration. And now I send a new one. Yeah, we will see when it's override. Yeah, so it's a new one. And as you can see, the server is different and the phone numbers. So only with the device number, and I know the phone number of the device, I can hijack the phone which already infected. So I can hijack. That's. Okay, so if we can hijack the phone, it's very good chance. Okay, create a fake server and just loot the phone. We have to reverse engineering the protocol, but all the stuff we have, encryption key, device number, we have everything to create a valid connection and we are able to loot the phone. So I implement a fin server. It's just barely the functionality which is needed to receive the collected file list and download it. So there are plenty other features which should be taken by a server, but it wasn't my aim. I just wanted to create a proof of concept code that hijack the phone and loot, collect all the data what was collected. So so how it look like? That's my server, and here is the input parameters, and they're just waiting for connections. Yeah. Here you can see the heartbeat interval. So how often it's trying to connect to the server. The minimum value is 1 minute, so we have to wait. And the network implementation of it is quite tricky because it's full with sleeps and stuff. So if you do not have a good connection, it could drop the connection. So as you can see, it's a valid handshake. That's the name of the device. It's coming from configuration. That's the email number. That's the location and counters. So, and as you can see, I just asked the phone to tell me the collected file list here, and then I just iterate and then use these files to get all the data from the device. And to have a better view, I just created the web stuff to list this. Yeah. So these are the messages here and here. So I was able to reconfigure the device and loot with my server with a better implementation. There are the contacts, so Don Corleone other malicious people. So I think it's a scary thing, because this application is for government and agencies who has the limited right to collecting and monitoring maybe malicious or evil person, but it has to be very strict and limited and secure, because it's private data, and they have to do it in a very good way, I think, because if you are just targeted people, your device is infected and malicious people can hijack your phone and loot it. It could be a very bad story, I think. That was the last known file I received from virus.total with a Jira script. It was obfuscated with Shield 4G. The scary thing, it still used the same way to be configured, the same byte were used, which for me it's very good, because for signature it's very representative. So if you use the commands, and the commands are more than 100, you are 100 chance to have a good detection for it. So I don't understand why they are still using this. What much worse is the AS key is still the same, and I seen so many versions of FinSpy, and the embedded key was always the same, which is very bad, I think. So in the version 4.21, you can hijack the phone very easily. You can reconfigure and loot it if you want it. And the latest version, the encryption key is always the same, and the only chance to have your own key is just 4 bytes, which is a joke, and it's very few. So for me, that means that this product has very good parts, because the SMS part, the configuration part, how they deliver the configuration, these are very good. So I think they are not stupid. But I think the encryption part is intentionally weak, to let other countries or some countries to be able monitoring and just ignore the encryption, because if you know the way, if you have this key, if you have this knowledge, it's very easy to defeat and get all the information. And this product sell over the world. They use by poor agencies who doesn't have the ability, the knowledge to analyze an application like this, just use it. And during this, they provide information for other countries about their interest and their targeted person. And so I think that would be, for me, that's the only reasonable thing why only 4 bytes could be used. Because in configuration, you can use any name for the device, and this name could be as long as you want. So the technology has the ability to use as long key as you would like to, but it's strict to 4 bytes. So that was the presentation, and if you have any question, it's welcomed.